Another strategy would be if you have radicals. The factoring and canceling strategy will not work, but what will work possibly would be a process called rationalizing the numerator. And I do want you to recognize that I did say numerator. This is a strategy that we'll use when we have radicals, and we use this quite a bit to help us find functions that we can work with. So again, as we talked about in our previous example, we always want to start with direct substitution. So your first approach, we want to plug in 16, and so 4 minus the square root of 16, and then in your denominator, 16 minus 16. Well, we get 4 minus 4, that's 0. We get 0 in the denominator. We have that indeterminate form again, which means the direct substitution fails. We have to try something else. This something else in this example, because we have radicals, is going to be the rationalization strategy. We're going to rationalize the numerator. Now we go back to our original problem. We're going to do the limit as x approaches 16. And we have 4 minus the square root of x over x minus 16. We're going to rationalize the numerator by multiplying both numerator and denominator by the conjugate of the numerator. So the conjugate of 4 minus the square root of x would be 4 plus the square root of x. I'm going to give you some additional strategies as I go through this example. One of them is your numerator you do want to multiply out. Your denominator you want to leave in factored form. Once again, remember you have not taken the limit, so you must use your limit notation. So we're doing the limit as x approaches 16. And we multiply out your numerator. So the 4 times 4 would be 16. The middle terms would cancel as we want them to do for rationalizing. And finally, when you take negative square root of x times positive square root of x, you get negative x. So your numerator is 16 minus x, but your denominator, don't multiply that out. Just leave it in factored form. Leave it as separated parentheses, but all in one denominator. And now we want to see if there's anything that we can cancel. Well, we could take the 16 minus x. Now, for the purpose of this video example, I'm going to go ahead and show you what's going on. I could factor out a negative 1, and that would make me have x minus 16. If you factor out negative 1 from the numerator, leave your denominator alone. And now I think you'll be able to see it a little bit easier. We are able to cancel the common factor in the numerator and denominator. Once again, we're doing all this algebra, but we have not yet done the limit. So continue to use your limit notation. The limit as x approaches 16, but now our fraction is simplified to negative 1 over 4 plus the square root of x. At this point, now we are ready to do the limit by making our substitution once again. So we'll have negative 1 over 4 plus the square root of 16. We want to plug in our 16. And that would simplify to negative 1 over 4 plus 4, giving us negative 1/8. So our original problem was the limit as x approached 16 of 4 minus the square root of x over x minus 16, and that gave me a negative 1/8. And just to drive home um, what you have found, again, you created a function that was equivalent to the original function, except for there was a hole in the graph at 16. And you created a new function. It was this one right here, equivalent to your original, but did not have the hole. And both of those graphs have a limit when x is approaching 16 of -1/8.